The geometric probability distribution is technically not a topic on the AP exam. However, it seems like every year it shows up in some way or another. So I'm just going to show you what it basically is. It's something you can figure out if given the time, but I'm making the time now, so we're going to figure it out. So let's say that you have a deck of cards, all right, and a well-shuffled deck of cards. And what I'm going to do is I'm going to draw a card out at random, so it's still a random variable. And I'm going to look at it. When I'm done looking at it, I'm going to put it back in the deck and shuffle it back up. All right, so I have independence going on because the outcome of one card is not going to influence the likelihood of the outcome of the other card. My probability is going to remain constant, just like it is in a binomial. It'll be equal to some number, and we're going to say it's equal to 1350 seconds. All right, because we're going to talk about the probability of selecting a clubs. All right, so the card I'm going to select is going to be, we're going to let P be the getting a club. All right, independence, probability is constant. There are two outcomes again. Either it's a club or not a club, so it's two outcomes. All right, but what changes is we're no longer going to have a finite set of trials. What makes it a geometric is we're going to find, so we're going to have P here, and then the probability of P is going to be the likelihood of getting, so this is the chance of getting a club on the Pth trial. All right, so what does that mean? If you're drawing cards and you're looking for a club, what's the soonest you could get a club? You could get it on the first try. All right, so what's the probability that you got a club on the first try? It's going to be 1350 seconds, so I'm just going to write 1/4. All right. What is the probability that your first club happens on the second trial? So then we're going to, okay, well, if it's on the second trial, then I'm going to like think off here to the side. I'm going to like, on the second trial, that means first, second. So it happens on the second, so that's a 4th. So what happened on the first trial? Well, on the first trial, it was not a club. And there are 3/4 that are not clubs, right? There's 75% of the cards are not clubs. So it's 3/4 times 1/4, or 3/16. All right, so then over here, I'm going to have 3/16. What's the probability that it happens on the third trial? All right, so it's like, all right, well then I'm going to go up here and let's quick erase this. All right, change it back over. And so now we're going to have a third trial. I'm going to add it to the front because the last trial is still a clubs over here. The one right before it was not a club, and the one right before that one is also not a club. So not a club, and then a club. So then that's 3 times 3 times 1. So that's 9, 4, 16, 9 64ths. All right, so that's then 9 64ths. All right. Then, and you could keep going on and keep going on and keep going on. 4, 5, 6, 7. The further you go down, the less and less likely it is it's going to be on that one. So sometimes probably goes up and then goes down, but this is a geometric, and I can make a little histogram out of all of these if I wanted to. But theoretically, a geometric probability distribution could go on forever. All right, and that's a geometric probability distribution. The expected value of a geometric probability distribution is equal to 1 over p. So if p is 1/4, I would do 1 divided by 1/4, dividing by a fraction and multiplying by a reciprocal. This is equal to 4. What that means is, on average, over time, I would expect that the first club will show up on the 4th trial. again, it kind of makes sense when you think about it. Like, well, there's 4 possible outcomes, so you'd expect it to show up about on the 4th time on average. Could be the 1st, could be the 8th, could be something, but over time on average, it's going to be the 4th. The standard deviation we really don't care about, and we can simplify this as well. So the 4th ends up being Q, what I don't want, to the 3rd times P. This one here for 3 was Q squared, what I don't want, which is 3/4 squared, times P. Q to the 1st times P. This is just P. All right. So when you're doing this, if you want to find like the 8th one, you look at this trend and say, all right, 4th is to the 3rd for Q, 3 is to the 2nd. So what I end up having is, for the 8th trial, I'm going to have Q to the 8 minus 1 times P. All right, so Q to the 7th times P. You could carry on. There's actually some other formulas that we could do with this, but this is the basic idea. And if you can figure this out, so then maybe you say, well, what's the probability that it happens on the 4th or later? All right, well, I would find 1, 2, and 3, add them up, subtract it from 1, and that would be the probability that my first club happens on or after the 4th trial. Go ahead and find that number just for funsies. Put it in the reflection response so you have something to do. It's a real simple calculation, but that's the geometric probability distribution. Technically not a concept, but it seems to show up every single time because they assume that you can just figure this out. So I figure might as well show it to you. There you go, folks. We'll see you in class.